G'day viewers. In this segment we'll talk about flooding, a useful primitive for routing. So flooding is a mechanism to broadcast a copy of a message from one node to all other nodes in the network. It's called flooding because it really works by making sure that the message appears everywhere. It's flood throughout the entire network, just like water going everywhere. This makes sure it'll be received by everyone. It's a simple mechanism, but somewhat inefficient, such that you wouldn't want to use it regularly a lot of the time. So here is the rule for flooding. Now I'll remind you that this is a distributed setting, so all nodes are executing this rule in parallel, concurrently, right? And none of them know the overall topology of the network. The rule for flooding is very simple. That's its virtue. Every node, when you receive an incoming message which is meant to be flood to the network, you simply send it out on all of your other links so it will reach all of your other neighbors except where it came from. Great. And there's one condition here just to make sure that we don't keep sending messages round and round in circles. You need to remember the message that you flood in some way so that if you see it again because it arrived at another path, you won't re-flood it and keep it going around the network. Flooding is inefficient because one node can receive multiple copies of the message along different network paths. And really, it only needed one copy of the message to see it. The copies that come along the other network paths are wasted in some sense. So let's go through an example just to see how flooding works. Same topology as before for our examples. We're going to flood from A. So I've shown the node that is busy doing the forwarding of messages. It starts at A. I've labeled A in red. A is going to flood the message by sending it to its neighbors. So it will send to B via AB and E via AE. And I've shown both of those floods in blue. So you can see that the message is propagated to the other nodes and has used some of the links. What happens next? So our message reached both B and E. So let me just circle the nodes which were reached. Both of these nodes should now flood. Let's look at B. B received the message from A, so flooding means it should send it on all of the other links. So it's going to send it to C, it's going to send it to E in this way, it's going to send it up to F, and it's going to send it to G. Similarly, E is going to flood by sending it to all of its neighbors. So it will send it down here to D, it will send it down to C, it will send it back to B, and it will send it to F. So you can see this message is really getting copied around the network. So F here has received two copies of it, one from B and one from E. It only wanted one, but it's got two. And B and E actually happen to do their flooding at the same time, so both of them have sent each other the same message. So it's crossed the link between them in both directions. This is what flooding can do. It'll really make sure the message gets everywhere. What next? Well, we've gone through A, B, and E. The other nodes which received the message most recently and haven't yet flooded it were C, D, F, and G. They all need to do their flood. Let's have C do the flood. C received two copies of the message, one from B and one from E. So it's going to send it to the other nodes. That's H and D here. D received the message from E, so it can send it to its other neighbor, that's C, down here. So you can see the message has crossed this link between C and D two times. Now F is going to flood. F's actually received a copy of the message on two links from B and E, so all F has to do is send down to G. And G similarly received it from B. It can send up to F. So F, in fact, you'll see here, is very fortunate or popular. It's got yet another copy of the message. So F has received a copy of this message along all of its links, and it's sent it out once. And finally, we've reached H. H has no one left to flood because it's at a dead end. And we're done with the flooding algorithm. You can see here that the algorithm was fairly simple, and it caused the message to be carried on each link at least once. Each link in at least one direction is maybe a better way to say that. So for a given link, it could have gone in both directions or only one. These pink arrows show you what happened. This is inefficient because really to reach nodes like F, we didn't need to send it along all of these links. We could have omitted many of these messages and we would have still broadcast the message effectively. So there are a couple more details I could tell you about flooding just to complete the algorithm. I said one of the keys here is to remember the message so that you can stop the flood eventually. Well, we only considered one message. This would be harder if many different nodes were using flooding. What is typically done is instead of literally memorizing the whole message, you will, for each source, associate a sequence number and put sequence numbers in the message. That way we might remember that A last flood a message with sequence number 7. If you ever see a message from A whose sequence number is 7 or lower, you know that you've already flooded and not to worry about it. If you see a message from A with a higher sequence number, you assume it's new, flooded, and then update your sequence number. And the flooding we saw was also unreliable. If you want to make flooding reliable, you can simply use the ARQ mechanism we saw. So when we flood and one node sends it to a neighbor, the neighbor can acknowledge that flood. And if the node doesn't receive the acknowledgement, then it can resend the flood message at a later time by using a timeout. This will make sure that we reliably send the information and reliably broadcast it to all of the nodes in the network. So now you know about flooding. Flooding is fairly simple, it's a little inefficient, but it's a good building block or foundation on which to build other more efficient protocols.